Hey everyone, welcome to your very first lesson of Theme 5, GCSE Geography. Now, the lessons are numbered a little bit strangely in this section because we'd already done the first 3 lessons in school together before the very first lockdown happened in March. So when I then started making the online lessons, the first lesson that went online was technically number 4 in the actual sequence because we'd done 1, 2, 3 in school together. But I'd numbered it number 1 online. So these first 3 lessons that I'm now coming back around to making to go up on Moodle will be lesson 1.1, 1.2, 1.3, and then 1.4, and you'll be into the sequence that's already up online, if that makes sense. So that explains the strange numbering on the folders, but yeah, it doesn't really matter. It doesn't make much difference. So the very first thing we're going to look at is the natural causes of climate change. Now, you hear the phrase climate change all the time at the moment, so we're going to drill down a little bit deeper into what we mean by climate change. So we're going to identify the natural factors that bring about changes in climate. You're going to summarise some information on the 3 main causes of natural climate change, and then we're going to create what's called a living graph, which is annotating a graph to explain its changes. So if you pause the video here a moment, go ahead and write down the title, and we'll get started. Okay, so there's a few key terms that we're going to be using in this lesson, but first off, what I want to discuss is what we actually mean by climate change. So, just have a think a moment. Tell me, what does cause climate change then? Don't need to write anything down, just have a quick think. Okay, so how many of you said pollution or thought pollution? Technically, yes, you are right. Changes in climate are brought about by pollution, and currently, whenever we talk about climate change, it's all to do with man-made causes of climate change that are going on at the moment, chiefly the burning of fossil fuels and the release, therefore, of greenhouse gases that are bringing about changes in our climate. But what we're looking at today is natural causes of climate change. Climate change that has been happening for millions of years, way, way, way before humans were ever a factor. So we're looking at natural causes of climate change today that have happened over much longer timescales. Next lesson, we will look at man-made causes of climate change that have come into play more in the last 50 to 70 years, but we're focusing on natural climate change today, and I just want to make that really clear. So, there's a few key terms you're going to need for today's lesson. Climate change, as I've just said, it's any change in climate, not necessarily brought about by man-made factors. It can be natural factors too. The Quaternary period, we give names to different epochs or periods of time in the Earth's history. We're currently in the Quaternary period. Glacials and interglacials, freezing cold periods, where you get an ice age, is a glacial. And the periods of time in between the ice ages are called meaning in between, interglacials. And aerosols. Aerosol particles are tiny particles of dust, volcanic ash, gas and things like that in the atmosphere. And they behave in a certain way to bring about changes in climate. So pause the video here a moment, go ahead and get those key terms down so we can get going. All right then, as I mentioned in the aims, there are 3 main natural causes of climate change that we're going to look at today that have been happening for millennia, way before humans were around. Volcanic eruptions, sunspots, and changes in our Earth's orbit around the sun. So what I'd like you to do, I'm just going to give you a little bit of verbal explanation first, because especially the Earth's orbit one can be quite tricky. Once I've verbally explained, I want you to go into the PowerPoint and copy and paste this link into YouTube and have a watch of that video up to about 3 minutes. It is about 4.5 minutes long. You can watch the rest if you like, but it's up to 2 minutes 54 that is important for us right now. So, let's start with sunspots. The sun is actually a star. It's a boiling hot ball of gas. It's about 6,000 degrees centigrade on its surface. Sometimes what happens is you actually get little parts of the Earth's surface that are cooler than others, okay? And they're called sunspots, these little dark spots here. Now, because these spots, these areas, are cooler in temperature, what happens is the rest of the sun's surface then has to produce more heat energy to maintain the average surface temperature around 6,000 degrees C. So what actually happens is, in periods of time where there are a lot of sunspots, a lot of cool patches, the rest of the sun's surface is working extra hard, putting out extra heat energy to make up for these cool spots. So what it actually means is, in periods of time where there are a lot of sunspots, the rest of the sun works harder, and it actually causes an increase in Earth's temperature. Volcanic eruptions, these are responsible for several mass extinctions in the past. When the Earth first formed, about 4.6 billion years ago, it was a boiling hot ball of liquid rock, and the outer layer then cooled to form the crust. But Earth's early life was very, very turbulent. There were lots of volcanic eruptions, and in a volcanic eruption, there's lots of different products. As you learnt in Theme 3, you get pyroclastic flows, you get lava, you get volcanic bombs, you get dust, ash, all kinds of tephra. But you also get aerosol particles. Now, the aerosol particles are tiny particles of dust or gas that go up into the Earth's atmosphere, and when they reach the upper layer of the atmosphere, they can't carry on going out into space. They spread out under the upper layers of the atmosphere, and what they do is they block out the sun. Aerosol particles reflect the sun's rays back out into space. So periods of time in the past when there's been lots of volcanic eruptions going on, it actually cools the Earth's climate because it reflects solar radiation back out into space. And the way that causes a mass extinction is, everything gets a bit cold, but that volcanic eruption cloud blocks out the sun. And as soon as there's not enough solar radiation reaching the ground, plants can't photosynthesize, and plants are the basis of the food chain. So the whole food chain collapses, everything starves to death. This last one, orbital changes. This is the most complex one. It's split into 3, okay? The way that our Earth moves around the sun isn't perfectly circular. It's actually slightly elliptical. Now, elliptical means egg-shaped, okay? It's not a perfect circle. It's a little bit egg-shaped. Now, the degree of egg-shapedness changes over time, okay? When the orbit is at its most eggy, okay, if you imagine it's more of an oval than a circle. So points in the year where the Earth is at the outermost edges of an oval, like over here and over here, what that does is it creates a cooler climate because the Earth is technically orbiting a little bit further from the sun. And then in years when the orbit is a little bit more circular, we're receiving a more constant level of radiation all year round, and so the climate will be a bit warmer. Now, that change in the shape of the orbit is called the Earth's eccentricity, and it changes about every 100,000 years. So the shape of the orbit is one thing. The other thing with our Earth is it's not perfectly upright. It's tilted slightly from being upright. And at the moment, we're at about 23 and a half degrees angle away from the vertical. That tilt varies over thousands of years. Sometimes we're tilted a little bit more towards the sun, so climate will be warmer. Sometimes we're tilted a little bit further away from the sun, so climate will be cooler. That variation in the Earth's tilt is called the obliquity, and it changes roughly every 41,000 years. Finally, the Earth isn't perfectly still on its axis of 23.5 degrees. It wobbles slightly on the axes, and the amount of wobble changes over thousands of years. In periods of time where the wobble is greater, the variation of solar radiation reaching the Earth is greater, and so the climate will be cooler. In periods of time where the wobble is less extreme, the solar radiation reaching the Earth is more constant, and therefore the climate tends to be warmer in those periods. This wobble of the Earth on its axes is called precession, and it varies roughly every 23,000 years. So you've got the eccentricity, the shape of the orbit, is the longest time scale variant, 100,000 years. The tilt is the medium timescale variant every 41,000 years. That's called the obliquity. And the wobble, the precession, is the shortest timescale orbital change, changing roughly every 23,000 years. Now, when those three things coincide at their most extreme, so the eccentricity is maximum, the obliquity is maximum, the precession is maximum, usually when they align, what that will cause is an ice age. It causes a glacial period. Ice ages happen roughly every 15 to 20,000 years. It's been 11,500 years since the last one. So we're approaching coming into an ice age technically. It doesn't all of a sudden go ice age overnight. It takes a couple of thousand years to actually come on into an ice age. And there's an argument that if man-made causes of climate change carry on as they are, then it will hold off the next ice age. We won't have one because we are artificially warming our climate. So you've got sunspots, volcanic eruptions, and 3 different ways in which our orbit around the sun changes. Watch this video and it should help cement your understanding a little bit further of what I've just explained verbally. Okay, so just to run through one more time because this is quite complex. Here's a breakdown of sunspots and here's a little video that tells you about sunspots. Okay, and it's quite a short term change. Temperatures will rise during a sunspot event. So about every 11 years or so, you get loads of sunspots. So the sun works extra hard with its output and you get a bit of a peak in temperature. If you pause the PowerPoint and copy and paste this link from the main PowerPoint, then you can watch a little bit more about sunspots. Volcanic eruptions. Here's an example of the kind of gas cloud that we're talking about that's full of aerosols. This is actually a pyroclastic flow. It will collapse back down the mountainside. This is from Mount Pinatubo in the Philippines in 1991. Pretty sure Pinatubo is the Philippines. Anyway, lots of aerosols and lots of climate changing gases erupted into the atmosphere. And finally, not finally, sorry. So if you can visualize, I spent way too much time on this, you can tell I get bored. So during an eruption event, not only will it cool the temperature of the Earth because the solar radiation is being reflected by the aerosol particles, but what it also does is it blocks out the sun. Solar radiation can't get to the plants. So how will the plants grow? Photosynthesis will stop. And then your herbivores and all your primary consumers, they've got nothing to eat. They'll starve. And if they die, then the other links in the food chain will die as well because they'll have nothing to eat. So this is what has brought about mass extinctions in the past is changes in climate. Solar radiation being blocked by volcanic eruptions, leading to extinction and destruction of food chains. Just a little side note. And then here's what we were saying about our orbital changes. Okay, and then there's another little link there that you can watch to further your understanding of eccentricity, obliquity, and precession, because it is quite complex. What I'd like you to do now is, accompanying this lesson, there's a text, okay? You've watched videos about these 3 natural causes of climate change. I've talked you through these 3 causes of natural climate change, and then I've written it in a text for you to use. If you're able to print it out, great. Highlight and underline the information like firsthand if you want. But basically, you can either use it on the screen or print it out. I want you to summarize that information into this table. So take an entire page, turn sideways in your book, make this table nice and big. This side only needs to be skinny, this column, because you're only writing these bits in. All right, make these columns much wider. In this column, I want you to give a little explanation of what the theory is all about. And in this column, I want you to tell me what that theory does to Earth's temperatures. When it's at its maximum or minimum, does it cause warming or cooling? Okay, I've filled in a few boxes to help you. So pause the video here, have a read of that text, re-watch those YouTube video links if you need to, and fill in this table with at least 1 or 2 sentences in each box to summarize how these theories work and how they bring about climate change naturally. Okay, now whenever we do this in class, it is really quite complex and you get a little bit stuck. So have a little look at what you've written in your table, have a little look at what I've written in my table, and see if there's anything that you need to change or summarise further or add. Okay. All right, what we're going to do now is see how well you've actually understood this. How do these theories link to real life changes in ice ages and non-ice ages, glacial periods and interglacial periods? Oh, I think I must have put that in the next lesson then by accident. Okay, what I will do is, I might have to re-record this. In the handout that goes with this lesson, you've got a graph that shows warming and cooling over time. It's like a squiggly up and down line, and the highest parts are interglacials when it's warmer, and the lowest parts are glacials when it's cooler. And you've got 6 annotations to go with the graph. What I'd like you to do is cut and stick the graph, and then cut and stick the annotations around the graph with arrows pointing to the right part of the graph. So you're creating what's called a living graph. The annotations explain what's happening in the graph. Okay? So any annotation that talks about warming, stick it down with an arrow pointing to an interglacial warm period. Any annotation that talks about cooling or ice ages, stick it down with an arrow pointing to an interglacial, a glacial cool period. Okay? And what I'll actually do is the video for lesson 1.2, I will go through that graph as the starter activity to recap your understanding of natural causes of climate change. Yeah, that's what we'll do. Just thinking on my feet here, okay? So what I'd like you to do to finish this lesson is cut and stick the graph and annotate it. If you don't have a printer, then you'll have to skip this one out, all right? But I would like you to have a look at it to see how well you actually understand it and whether you'd be able to match the annotations correctly. But if you do, please print out the graph, stick it down with room to put the annotations around it, and then you can cut and stick the annotations. Anything to do with warming, stick it down and point to a warm period on the graph. Anything to do with cooling, stick it down and point to a colder ice age period on the graph. And I'll run through it as the starter to the next video. So that concludes lesson 1.1 of theme 5. If you have any questions, drop me an email, gleesona@hubcymru.net. Otherwise, I will see you soon for lesson 1.2.